When we're graphing linear inequalities, basically, ladies and gentlemen, what we want to simply do in graphing linear inequalities is just graph each one of these equations separately. So you guys can see here, I have this equation that's in standard form. When we have an equation in standard form, we can graph it either using substitution method or, intercept method, or by rewriting it into slope-intercept form. I prefer to use slope or intercept method when my two coefficients evenly divide into my constant. All right? So I'm going to go over that method for you guys. However, if you always wanted to write this, you can always graph it by rewriting it into slope-intercept form. And again, to do that, you just rewrite it into y equals mx plus b form, right? And then you guys should know how to graph, hopefully. So you'd have 2y minus 4x is less than 12. And then you divide by 2. So y is less than negative 2x plus 6. Hopefully you guys know how to graph that by this. But I'm actually going to teach how to graph that a little bit differently. The intercept method is basically you just identifying what are the x and the y intercepts. And for a second, I'm going to rewrite this as an equation and say the x-intercept, where the graph crosses my x-axis, which is right here, the y value. Remember when we're talking about like number lines? Here's a horizontal number line. Here's a vertical number line. Wherever a point lies on the x-axis, the y value is equal to 0. So you just plug 0 in for y and solve for x. And the reason why intercept method is important for these coefficients to divide into your constant, because if it doesn't, then you're going to be dealing with fractions. So x equals 3. 1, 2, 3. Then I go to the next one. The y-intercept is when x equals 0. So now I plug 0 in for x. So now I go to 6. 1, 2, 3, 4, 5, 6. Make a point. Now before I connect them, I got to go and look at my inequality symbol. Remember, my inequality symbol is less than. That means my line is not going to be a part of the solution, so it's going to be a dashed line. Correct? OK. Then I need to test the shading. So to test the shading, we need to use a test point. And the best test point to always pick, as long as the line does not go through that test point, is 0, 0. So remember, that coordinate point is 0, 0. So all you simply do is plug that in for x and for y. So I do 4 times 0 plus 2 times 0 is less than 12. 0 is less than 12. Is that true or false? True. So since that test point is true, I'm going to shade towards the test point. All right? Now we need to graph y is less than 3. So to do that, I always like to graph y is equal to 3. So I go over to 3, or y equals 3. 1, 2, 3. So y equals 3 at 0. Well, what about when x equals 1? What does y equal? What will y be? Forget about the inequality. At x equals 1, what does y equal? What does y always equal? I'm listening for somebody. What does y always equal? What does it say y it has to equal? 3. So here, y equals 3. What about when x equals 2? What does y equal? 3. What about when x equals negative 1? What does y equal? 3. So y equals or less than 3 is this horizontal line. Again, it's less than. That's going to tell us it's a dashed line. And now, again, we need to apply our shading. Well, we don't have an x and a y to plug in for this. But we can just apply 0 in for y. We don't have an x to plug it in. Now, is that true or false? True. So now you shade below the line. And you can see the region that is true for both my inequalities is right here.
Wait, do you shade on that side too?
I'm only going to have you guys shade where it's true for both of my inequalities. OK? And that's it.